The National Electrical Code is a regionally adopted standard for the safe installation of electrical wiring and equipment in the United States. First published in 1897, the NEC is updated and published every 3 years by the NFPA, offering valuable information and guidance for electrical installation best practices. The learning objectives for this training module are: evaluate NEC hazardous locations, recognize hazardous applications and associated protective methods, define hazardous substance groups, and examine hazardous protective methods and electrical product protection. The first type of hazard is created by the presence of flammable gases or vapors in the air, such as natural gas or gasoline vapor. When these materials are found in the atmosphere, a potential for explosion exists, which could be ignited if an electrical or other source of ignition is present. The code writers have referred to this type of hazard as Class 1. So a Class 1 hazardous location is one in which flammable gases or vapors may be present in the air in sufficient quantities to be explosive or ignitable. Some typical Class 1 locations are petroleum refineries and gasoline storage and dispensing areas, dry cleaning plants, where vapors from cleaning fluids can be present, aircraft hangars, and utility gas plants and operations involving storage and handling of liquefied petroleum or natural gas. The second type of hazard listed by the National Electric Code are those areas made hazardous by the presence of combustible dust. These are referred to in the code as Class 2 locations. Finely pulverized material, suspended in the atmosphere, can cause as powerful an explosion as occurring in a petroleum refinery. Some typical Class 2 locations are grain elevators, flour and feed mills, plants that manufacture, use, or store magnesium or aluminum powders, producers of plastics, medicines, or fireworks, producers of starch or candies, spice grinding plants, sugar plants, or cocoa plants, and coal preparation plants or other carbon handling or processing areas. Class 3 hazardous locations, according to the NEC, are areas where there are easily ignitable fibers or flyings present due to the types of materials being handled, stored, or processed. The fibers and flyings are not likely to be suspended in the air, but can collect on machinery or lighting fixtures where heat, a spark, or hot metal can ignite them. Some typical Class 3 locations are cottonseed mills and facilities that shape, pulverize, or cut wood and create sawdust or flyings. In addition to these types of hazardous locations, the National Electric Code also concerns itself with the kinds of conditions under which these hazards are present. The code specifies that hazardous material may exist in several different kinds of conditions, which for simplicity can be described as first, normal conditions, and second, abnormal conditions. In the normal condition, the hazard would be expected to be present in everyday production operations, when the hazardous material is expected to be confined within closed containers or closed systems and will be present only during accidental rupture, breakage, or unusual faulty operation. The situation could be called abnormal. The code writers have designated these two kinds of conditions very simply as Division 1 normal and Division 2 abnormal. Class 1, Class 2, and Class 3 hazardous locations can be either Division 1 or Division 2. Good examples of Class 1 Division 1 locations would be the areas near open dome loading facilities or adjacent to the relief valves in a petroleum refinery, because the hazardous material would be present during normal plant operations. So far we've covered the three types of hazardous locations: Class 1, gas or vapors, Class 2, dust, and Class 3, fibers and flyings. And secondly, two types of conditions: Division 1, normal conditions, and Division 2, abnormal conditions. Now let's move on to discuss the nature of hazardous substances. The gases and vapors of Class 1 locations are broken into 4 groups by the code: A, B, C, and D. These materials are grouped according to the ignition temperature of the substance, its explosive pressure, and other flammable characteristics. The only substance in Group A is acetylene. Acetylene makes up only a very small percentage of hazardous locations and is a gas with extremely high explosion pressures. Group B is another relatively small segment of classified areas. This group includes hydrogen and other materials with similar characteristics. By following the NEC code, some of these Group B locations, other than hydrogen, can actually be satisfied with Group C and Group D equipment. Group C and Group D are by far the most usual Class 1 groups. They comprise the greatest percentage of all Class 1 hazardous locations. Found in Group D are many of the most common flammable substances, such as butane, gasoline, natural gas, and propane. In Class 2, dust locations, we find the hazardous materials in Group E, F, and G. These groups are classified according to the ignition temperature and the conductivity of the hazardous substance. Conductivity is an important consideration in Class 2 locations, especially with metal dust. Metal dusts are categorized in the code as Group E. Included in here are aluminum and magnesium dust and other metal dust of similar nature. Group F atmospheres contain such materials as carbon black, charcoal dust, coal, and coke dust. In Group G, we have grain dust, flour, starch, cocoa, and other types of materials. In summary, hazardous locations are classified in 3 ways by the National Electric Code: type, condition, and nature. There are 3 types of hazardous locations: Class 1, gas and vapor; Class 2, dust; and Class 3, fibers and flyings. There are 2 kinds of hazardous conditions: Division 1 normal and Division 2 abnormal. And finally, there is the nature of hazardous substance, where we find Groups A, B, C, and D in Class 1 locations, and in Class 2 locations, Group E, F, and G. Understanding the National Electrical Code is essential to properly identifying and specifying correct electrical products. Now that we've completed our code translation, we're ready to move on to the next part of our discussion: hazardous location equipment. To do so, let's first take a look at the ways in which electrical equipment can become a source of ignition. The 3 predominant methods are arc or spark, high temperatures, and electrical equipment failures. Arc and sparks are produced by normal operation of equipment like motor starters, contactors, and switches. As the name describes, these types of devices create arcs that could potentially ignite a hazardous location atmosphere. The high temperatures of some heat-producing equipment, such as lamps and lighting fixtures, can ignite flammable atmospheres if they exceed the ignition temperature of the hazardous material. The National Electric Code requires special markings of heat-producing equipment with temperatures above 100 Celsius or 212 Fahrenheit. Electrical equipment failure is another way an explosion could be set off. A burnout of a lamp socket or shortening of a terminal could spark a real disaster in a hazardous location. Now let's get down to the specific hardware and how it is designed and constructed to be suitable for hazardous locations, starting with those designed for Class 1, gas or vapor applications. The first requirement for a Class 1 enclosure is strength. The enclosure must be strong enough to contain the explosion within, and the walls must be thick enough to withstand the internal strain. It also has to be explosion-proof in case gas or vapors get inside. Secondly, it must function at a temperature below the ignition temperature of the surrounding atmosphere. The equipment must also provide a way for burning gases to escape from the device as they expand during an internal explosion, but only after they have been cooled off and their flames have been quenched. This escape route for the exploding gases is provided through several types of flame paths. An example is the ground surface flame path. Here, the surfaces are ground, matted, and held to a tolerance of 15 ten-thousandths of an inch. This permits gases to escape, but only after they've been sufficiently cooled, so they won't ignite the volatile surrounding atmosphere. Another example of the flame path is the threaded type. After an explosion, the gas travels out through the threaded joint, but as it does, the explosion cools off, allowing the flame to not ignite the hazardous atmosphere. However, in the case of Class 2, the assumptions are different, and in turn, the design is different. In Class 2, the explosive dust is kept away from equipment housed within the enclosure, so that no internal explosion can take place, and there is no longer a need for any heavy explosion-containing construction or flame paths. This difference explains why Class 1 Division 1 equipment can be called explosion-proof, and Class 2 equipment is called dust ignition-proof. Class 2 equipment has a different set of requirements. 1. It must seal the outside dust. 2. It must operate below the ignition temperature of the hazardous substance. And 3. It must also allow for a dust blanket, which is the buildup of dust collecting on top of the device that can cause it to run hot and ignite the surrounding atmosphere. For Class 3 equipment, there is very little difference from the design of Class 2. Class 3 equipment must minimize the entrance of fibers and flyings, prevent the escape of sparks, burning material, or hot metal particles resulting from the failure of equipment, and operate at normal temperature that will prevent the ignition of fibers accumulated on the equipment. There are many enclosures, devices, and fixtures suitable for all three classes. This simply means that it meets the specifications for each individual type. A Class 1 device, which could contain an explosion of a specific gas, would also have to prevent dust from entering the enclosure to be suitable for Class 2. The close tolerance of the flame path, which cools the burning gases, is also close enough to exclude explosive dust so that the gasket would not be needed. Proper installation of hazardous location equipment calls for the use of seals. Special fittings are required to keep hot gases from traveling through the conduit system, igniting other areas in the event of an internal explosion. They are also needed in certain situations to keep flammable dust from entering the dust ignition-proof enclosures through the conduit. When arcs and sparks cause ignition of flammable gases and vapors, the equipment contains the explosion and vents only cool gases into the surrounding hazardous area. Sealing fittings are designed to be filled with a chemical compound after the wires have been pulled. As the compound hardens, it seals passageways for dust and gases. Within each conduit run that enters an enclosure for switches, circuit breakers, fuses, relays, resistors, or other apparatus which may produce arcs, sparks, or high temperatures within hazardous locations, conduit seals should be placed as close as possible and in no case more than 18 inches from the enclosure. In summary, NEC hazardous locations are classified in three ways: type, condition, and nature. The types are gas, vapor, dust, and fibers or flyings. The conditions are normal or abnormal, indicating the probability of hazardous materials in the atmosphere. And the nature dictates the explosive pressure and flammability of hazardous substance within the environment, indicated by letters A through G. All equipment within hazardous locations must protect against three predominant types of ignition: arc or spark, high temperature, and equipment failure. Within NEC-rated materials, the design and construction must have high strength, a path for explosive materials to be extinguished, or provide protection from dust buildup. Wherever you are drilling, pumping, or refining, Cooper Industries knows the codes and standards required within hazardous environments. Our products are built to meet certifications applicable within NEC environments for locations around the world to ensure the safety of your employees and equipment.